In question 33 in chapter 10 of our physics textbook, it talks about a 25 kilogram child is sliding down a playground slide at a constant speed. The height of the slide is 3.0 meters and the length of the slide is 7.0 meters. And it wants to know, using the law of conservation of energy, what the kinetic friction force is, that is what the magnitude is that is acting on the child. So in order to do this question, once we've written down the information that we've been provided, what we can do is use this equation here, which will calculate our kinetic energy generated from like the slide. So if we input the values we have, we should get the mass, which is 25 kilograms, times by gravity, which is 9.8, times by the height, which was 3.0 meters. If we put that in our calculator, we should get 735. That'd be in joules. So that's the kinetic energy that we have currently, and the reason why we got joules is because kilograms times meter squared over second squared would be joules. So once we have that, we need to calculate the change though in the energy, or to calculate like what we need to put into this final equation here. And so the reason why we do that is because when they're going down the slide, it's at a constant speed, but once they reach the bottom, the height is 0 and the gravitational force is 0 as well. So in order to take this into account, we have to do 0 minus our calculated kinetic energy, which will give us a change in energy is equal to negative 735 joules. And then once we have this, we can insert it into our equation here, because the energy change is equal to the work. So once we do that, we can use this equation that the work equals the negative force times by the length of the slide. And when we rearrange it down to where we get the force, we get force equals the work over the length of the slide. And so we insert the information that we have, and we'll get negative 735 joules. And because the net force is negative over here, our length of the slide has to be negative, so we do 7.0 meters, which would give us a value of 105 newtons. And that's the answer to question 33 in chapter 10 of our physics textbook.